Hi guys, this is Dr. G here, and in this short video I'm going to briefly discuss the three techniques that we use to draw organic structures. So the first method that we use is called expanded structures. This is the simplest way of drawing organic structures, and then the step up method, or the second method that we are going to talk about, is called condensed structures. And of course the most advanced way of drawing organic structures are known as skeletal structures. So as organic chemistry students, it is very important that you guys know how to draw organic molecules using any of these three methods. Okay, so it is very important that you guys know all three of these methods so that you can understand organic chemistry. So let's first talk about the simplest type of structures called expanded structures. So by now you should know that in organic chemistry we are dealing with carbon, and carbon is in group 4a. So it has 4 valence electrons. It has 4 valence electrons, which means in order to obtain the electron octet or the noble gas configuration, carbon has to make 4 bonds. Carbon has to make 4 bonds. That is the most important thing to remember when drawing organic structures. Always try to give 4 bonds to carbon. That is very important. There are exceptions, but of course 99% of the time carbon will have 4 bonds. Carbon will have 4 bonds. So when you are drawing any structure, always try to give 4 bonds to carbon. So in the expanded structure, what we do is we draw each carbon, and then we draw 4 bonds, and then you try to give 4 other groups or atoms to those 4 bonds. It could be hydrogen or it could be another carbon, and then each carbon should have 4 bonds. Okay, each carbon should have 4 bonds, and then these 4 bonds must be attached to something else. These 4 bonds must be attached to something else. So this is very simple. As you can see, you will always draw 4 bonds to carbon. You will always draw 4 bonds to carbon, and then you will attach a group of atoms or an atom to those each of those bonds. Okay, and the easiest way to draw the 4 bonds is by drawing the 4 bonds perpendicular to each other, okay, in 90-degree angles, and then attach the other atoms to it. Okay, so sometimes you might have sp2 hybridized carbons. Okay, that means carbons with a double bond. Okay, that means that carbon already has 2 bonds. Okay, so you need to have 2 additional bonds. Okay, so this could be another carbon, hydrogen, and this carbon should also have 2 more bonds, and let's say those are also hydrogens. Okay, so when drawing expanded structures, always remember to draw all 4 bonds around carbon, and each of those 4 bonds has to have something attached. Each of those 4 bonds has to have something attached, and most probably those 4 bonds are going to have another carbon or a hydrogen. Okay, another carbon or a hydrogen. Okay, that is expanded structures. So if you have a sp hybridized carbon, that means a carbon with a triple bond. If you have a carbon with a triple bond, then each carbon already has used three of its 4 bonds, so they only have one other bond. So give that to another atom. Okay, so always remember to give 4 bonds to each carbon. That is important. All right, so the second method that we are going to learn is called condensed structures. Okay, so in the second method we are going to talk about condensed structures. So in drawing condensed structures, okay, in drawing condensed structure, we follow 2 things. Okay, we usually do not write carbon hydrogen bonds. Okay, we usually do not write carbon hydrogen bonds. Instead, we write the hydrogens next to carbon. We write the hydrogens next to carbon. Okay, so let's try out a molecule. Okay, let's try out a molecule. Let's say you have something like this with a 2 carbon structure. Okay, so here is the expanded structure for 2 carbons. Of course, the other 6 bonds are with hydrogens. So when you are writing the condensed structure, what you do is you write the hydrogens of each of the carbons. So if you take this carbon right here, let's say this carbon is carbon number 1, this carbon is carbon number 2. Okay, so when you are considering carbon number 1, it has 3 hydrogens, right? It has 3 hydrogens, so put 3 hydrogens next to it. Okay, next to it. So don't write the carbon hydrogen bonds. And then here comes the second carbon, carbon number 2, and it also has 3 hydrogens, so put 3 hydrogens next to it. Okay, and sometimes you can even remove carbon-carbon bonds. Okay, so when drawing condensed structures, you can stop here, you can stop in this step, or you can even remove carbon-carbon bonds. If you remove carbon-carbon bonds, your molecule structure will look like this: CH3 CH3. Okay, so both these are acceptable for condensed structures. I actually prefer this one right here, where I draw the carbon-carbon bonds and I only put hydrogens on carbons. But even in textbooks and in other places, you may also see this method where you will basically only write the carbon hydrogen labels and you will not show any bonds. Okay, both of these are correct. Both of these are correct. Let's take another example. Let's say you have a double bond in your structure. Okay, let's say something like this. Let's consider this molecule. Let's label the carbons. Let's call them carbon number 1, carbon number 2, carbon number 3. These are hypothetical labels. Okay, you don't have to label them. All right, so let's draw this structure now. We are trying to draw the condensed structure. Okay, so when drawing condensed structure, you can you don't have to show carbon-carbon single bonds or carbon-hydrogen bonds. Okay, but I usually keep the carbon-carbon bonds. I only remove, or I try not to show carbon-hydrogen bonds. So starting with the third carbon, you can say third carbon, it is a CH3 because it has 1 carbon attached to 3 hydrogens. So it's CH3, and it has a single bond to a carbon number 2. Am I correct? All right, and carbon number 2 has a hydrogen, and it has a double bond. It has a double bond with carbon number 1, and then comes the 2 hydrogens. Okay, CH3 CH CH2. Okay, so this is one way to do it. Or you can even remove the carbon-carbon bonds and then you can only show labels. That is also correct. So if you want to do that, that is a bad arrow. If you want to just show the carbon hydrogen labels, you can do that. That will be CH3, excuse me, CH2. But I mean, I would prefer if you draw the carbon-carbon bonds, because it basically helps you understand the structure better. Okay, at least in the beginning, I would recommend you to keep the carbon-carbon single bonds. Okay, keep the carbon-carbon single bonds. Carbon-carbon bonds, and then remove the carbon-hydrogen bonds. Okay, so you can do this, or you can even draw it like this. But I prefer if you keep all the carbon-carbon bonds. Okay, I prefer if you keep all the carbon-carbon bonds. All right, so those are condensed structures. And then comes the most advanced way of writing organic structures, which we call skeletal formulas. That is the most advanced method. So most of the times we use skeletal formulas in organic chemistry. Why? Because it saves us a lot of time and space. Okay, if you take a look at expanded structures, you need a lot of space to write molecular structures, right? A lot of bonds going around, and then it takes too much time and space to do expanded structures. Condensed structures actually saves you some time and space. Okay, but skeletal formulas actually saves you a lot of time and space. Okay, and it is very easy to draw them. Why? Because in skeletal formulas, okay, you don't show carbon hydrogen bonds. That is one. Okay, so no carbon hydrogen bonds, you don't show them. Okay, so no carbon hydrogen bonds, that is one. And then secondly, you don't show carbon labels and hydrogen labels, so no hydrogen or carbon labels. Okay, no hydrogen or carbon labels. And then if you have any other atoms like oxygen or nitrogen, the secondary atoms that we discussed earlier, then you can write those labels. But the only labels that you don't write are carbon hydrogen labels. Okay, so in an organic molecule, we tend not to show any carbon hydrogen labels. So all you have is what? Carbon carbon bonds. All you have is carbon carbon bonds. Okay, or bonds between carbon and any other secondary atoms. So those are the things that you have. Okay, so let's see how this looks like. Let's take a simple molecule. Okay, let's take something like a 4 carbon alkane. Okay, CH3, CH2, CH2, CH3. Okay, so here is an alkane. Okay, it has 4 carbons, and of course for 4 carbons you have 10 hydrogens. And when you are writing skeletal structures, all you need is the carbon carbon bonds, right? So basically you are removing all the carbon hydrogen labels. So basically what you have is this: CH3, CH2, CH2, CH3, and then you're removing all the carbon hydrogen labels. So all you are left with is the carbon carbon bonds. Am I correct? All you are left is the carbon carbon bonds. And basically in this concept, you have to understand that every end and a bend is a carbon. So when you have 3 lines, you have to connect the 3 lines. So you do it in a zigzag manner. Okay, so 1 line, 2 lines, 3 lines. Okay, so that is all we have, right? 1, 2, 3. But when you are connecting the lines, okay, you do it in a zigzag pattern. You don't just connect it in a hole like this, 1, 2, 3. Then no one knows if this is a connection or just a continuous line, right? So when you are connecting the remaining carbon carbon bonds, you do it in a zigzag pattern. So you always try to go like this. Okay, you always try to go like this in a zigzag pattern. Okay, so you have 3 lines, so basically you connect them in a zigzag pattern. And as I mentioned earlier, in these skeletal formulas, okay, every end and a bend is going to be a carbon. Okay, so right here, this is an end, right? So this is a carbon, this is an end, this is a carbon, carbon carbon. Every end and a bend is going to be a carbon. So how do you know how many hydrogens these carbons have? Okay, so let's take carbon number 1. Okay, let's take carbon number 1. So if you take carbon number 1, it only has 1 carbon carbon bond, right? It only has 1 carbon carbon bond. So the remaining 3 bonds should be with hydrogen. If you take carbon number 1, you can only see 1 bond going out of it, right? So the remaining 3 should be hydrogens. So if you take carbon number 2, it has 2 carbon carbon bonds. So the remaining 2 bonds should be with hydrogen. If you take carbon number 3, you know carbon has to have 4 bonds. Out of the 4 bonds, this carbon number 3 only has 1, 2. Only 2 bonds, right? So minus 2, you have to have 2 hydrogens. Okay, count your fingers, that is perfectly fine. Okay, so if you take carbon number 4, it only has 1 carbon carbon bond, so the remaining 3 should be hydrogens. Okay, 4 minus 1 is 3 hydrogens. Okay, so every end and a bend is going to be a hydrogen. So the skeletal formula for butane, okay, for carbon alkane, which is this one, is this. This is the correct answer. All right, so these are the 3 methods that we use to draw organic structures. These are the 3 methods that we use to draw organic structures. Okay, so let's do one more example for a skeletal structure. Okay, let's say you have a skeletal structure like this. Okay, let's try to decode the skeletal structures. Let's say you have a skeletal structure like this one. There you go. So this is your skeletal structure. So someone asks you to draw the condensed structure. Someone asks you to draw the condensed structure. So you have to convert this whole thing into a condensed structure. So you basically keep this pattern. Okay, you basically keep this pattern. Okay, so you are basically tracing through this skeletal structure, because we know the skeletal structure is what? It is the carbon-carbon bonds, right? Carbon-carbon bonds, and we don't write any carbon or hydrogen labels. So you keep this structure, and then you know that every end and a bend is a carbon, right? So these are carbons. So this particular molecule has 5 carbons. This particular molecule has 5 carbons. Okay, this particular molecule has 5 carbons. So now we have to fill in the hydrogens. Okay, so carbon number 1 only has 1 bond. Okay, it has to have 4, but it only has 1. So it has to have 3 more hydrogens so that it will have all 4 bonds. Carbon number 2 has 2 bonds from the double bond and 1 from this single bond. So it already has 3 bonds out of the 4. How many remaining? 4 minus 3 is 1. Okay, so then you have a double bond. Okay, and then carbon number 3 has 1, 2, 3, 4. It has all 4 bonds. So this carbon is good. It doesn't have to have any hydrogens. Why? Because it has all 4 bonds. Double bond, that is 2 bonds, 3, 4. So this is carbon number 4. If you take carbon number 4, it only has 1 bond yet. So it has to have 4 bonds. It only has 1. So how many hydrogens does it need? It needs 3 hydrogens. And then carbon number 5, it only has 1 bond. So to have 4 bonds, it has to have 3 other hydrogens. Okay, so this will be your condensed structure. Okay, and the other thing to remember is that if you have a hydrogen on, let's say, nitrogen, then you have to show those hydrogens. Okay, this is another skeletal structure, but in skeletal structures we typically don't show carbons or hydrogens that are directly attached to carbons. Okay, so if the hydrogens are directly attached to other atoms like nitrogens, oxygens, or things like that, then you have to show those hydrogen labels. Otherwise nobody will know. Okay, nobody will know. So that is all I need to tell you about these 3 structures. I hope that you understood it, but of course in class we will do a lot of examples and then practice ourselves in drawing these structures more efficiently. Okay, please let me know if you have any questions. Okay, you guys have a good one. Take care.